Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at parabolas. So a parabola is just a graph of a quadratic equation, and we can write any quadratic equation y equals ax squared plus bx plus c. So by the end of this video, I want to be able to give you any equation that looks like this, and you turn it into a graph. So in order to do that, we're going to calculate four features of the parabola, plot them, and then join them up. So when we're graphing parabolas, we're going to identify these four features. So firstly, the concavity, whether it's concave up or concave down. So if a, the number in front of x squared here, is positive, it's concave up. That basically means it's a smiley face. And if a is negative, this number in front of x squared is negative, it's concave down, which means it's a frowny face. So secondly, we calculate the y-intercept. A parabola always has one and only one y-intercept. So if it's written in this form, this value c will be the y-intercept, because that is what's left when you let x equal 0. So thirdly, we're going to find the x-intercepts. We do that by taking our equation and changing y to 0. We then solve the resulting quadratic. Of course, quadratics can have 0, 1, or 2 solutions, so a parabola has 0, 1, or 2 x-intercepts. And then finally, the axis of symmetry is given by this formula, x equals minus b over 2a. That's also the x-coordinate of the turning point, using the same formula. You then find the y-coordinate of the turning point by substituting this number into the original equation. All right, let's look at an example. So let's look at this example here, y equals x squared plus 2x minus 3. So we're going to calculate each of the four features. So firstly, the number in front of x squared, a, is equal to 1. That's clearly positive, so this will be concave up and a smiley face. Secondly, the y-intercept is just the constant term, minus 3. If x equals 0, y equals minus 3. So as coordinates, the y-intercept is 0, minus 3. All right, let's look now at finding the x-intercepts. So to find the x-intercepts, we take our equation and we change y to 0. We're now going to solve this quadratic. So this one's probably easiest to factorize. So two numbers that multiply to negative 3 and add to 2 are positive 3 and negative 1. So that means that the two solutions are minus 3 and positive 1. They are the two x-intercepts here. This has two x-intercepts. All right, so part 4, we're going to use the formula x equals minus b over 2a. So b, the number in front of x, is 2. So it's minus b over 2 times a is 1, as we said before. So we get x is minus 1. So x equals minus 1 is the axis of symmetry. It is also the x-coordinate of the turning point. So to find the y value of the turning point, we substitute in minus 1. Whenever you're substituting a negative into a formula, you must use brackets. Substituting x is minus 1 in this way gives me y is minus 4. So the turning point is minus 1 minus 4. So we're going to put all of that into a graph now. So we draw up our axes, and now we're going to plot all these features. Well, we can't really plot the first one, but that will help us when we plot it. So the second thing was the y-intercept at minus 3. So I'm going to plot that down here. Then we had x-intercepts. One of them was at minus 3. One of them was at positive 1. The turning point I figured out was minus 1 minus 4. So that's down here. So because it is a smiley face, it's going to come through the x-intercept down here, stop at the turning point, turn around, that's why we call it a turning point, and go in the other direction. So you must put arrows on the end, and you should also label the equation. Please also make sure you label your axis, not just with the x's and y's, but you need numbers along here. This intercept is only right if I label it as minus 3. All right, I'm going to get rid of this and do one more example. Please pause and copy down if you need. All right, let's now go and graph y equals minus 4x squared plus 12x minus 9. Equation might look a bit different, but we're going to find all of these four features just as we did in the previous example. So firstly, the number in front of x squared a is negative 4, so that means it will be concave down or a frowny face. So secondly, this number by itself, minus 9 this time, is the y-intercept. So let's now find the x-intercepts. So we take our equation y equals minus 4x squared plus 12x minus 9, and we solve when y equals 0. Now this is non-monic, the number in front of x squared is not 1. So we went through a few different ways to solve this, but by now you've probably figured out that the quadratic equation is the simplest way to do that, the quadratic formula, that is. So let's use the quadratic formula. So the discriminant is b squared minus 4 by a by c. Now that actually equals 0. So there is one solution to this equation, meaning this parabola will have one and only one x-intercept. So now, using the quadratic formula, we get x equals minus b plus or minus the square root of the discriminant, which is 0, over 2 times a. So the only solution is minus 12 over minus 8, which is 3 over 2, or 1.5. Alright, finally we're going to calculate axis of symmetry and turning point. So x will be minus b over 2 times a, and you get x equals 3 over 2, or 1.5. This isn't a coincidence. Whenever you have one and only one x-intercept, it's also the turning point. So I don't need to go any further. I know that the turning point is going to be 1.5, which is 3 over 2, 0. So let's plot all these features. So the y-intercept of minus 9 is down here, and there's one x-intercept at 1.5. So we can just estimate that. That'll be about there. So that's also the turning point. Now here we only have 2 points. Now we know that it is going to come up like this, stop and turn around, because it is a frowning face. But using another point, we might also note that this turning point always lies on the axis of symmetry. So to go from this point to the axis of symmetry, we've gone across 1.5. So we could go across another 1.5 and we'd have a point here. So if all of this working out doesn't give you 3 points that lie in the parabola, you can just substitute any value of x you want to find a third point. I just use the axis of symmetry in this case. Now I have 3 points. That's enough to characterize the parabola. So it comes through the y-intercept. It's going to go up. It's hitting the turning point, stops, turns around, and then goes the other way. We need arrows on both ends, and we're going to label the equation. And then we just make sure that our axes are labeled x and y, and also the numbers as well. Then we're done. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.